So, as we discussed, linker plays a very important role, which decides which portion of code should go at which address. I believe you are already aware of C programming memory layout. We have the heap, we have the stack. So, at the bottom, you will have the .text. Okay, .text is nothing but the code. Above the text, we will have our data section. So in the data section, first you will have your initialized, then uninitialized data, and then we have the stacks. We can have the user-defined sections also. What we call this basically the memory layout, C memory layout. Linker software will manage all these things. Obviously, it will take the help of linker file or script. In the linker file, we define that what is the size of my flash memory, what is the size of my RAM. And linker takes that. Also, it takes the object files. So suppose if this kind of some code you have, it will be taken in the form of .o object file. This object file will come from here to linker. Then linker will check whether whatever the size of your code, okay, so from this place to this place, whatever the size you have, whether it will fit into this text area or not. Whether this size and this size, worst case they could be equal. The best case will be that this size will always be lesser than this size. Okay? Even it will keep track of each and every address, at which address what code went. Linker will even know that at this address which code is there. If you will ask the linker can tell you also. There is a very special file, .map file. So if you will see in this case, we have a global variable that is int c, and this is uninitialized. So C will go into this section. This is int D, that is initialized. D will go into this section. Inside variables int A and B, those are the local variables. So A and B will go into the stack. Now we discussed about one more special file, that was the startup file. The startup file is more close to the hardware. So this is your memory layout. When our microcontroller start, when booting process happens, so first file which will run, that will be startup.s. What are the contents of the startup file? So it will have the reset handler, it will have all the interrupt related things, then it will have RAM initialization. So the first thing will execute after the microcontroller will get boot up, that is your reset handler. So this is the first piece of code which is going to execute when your microcontroller will boot up. Generally we try to keep the startup code things at the beginning of the address. After the reset handler, we will have the ISR, interrupt service routines. Interrupt service routines are nothing but they are the special kind of function, and each ISRs is related to one interrupt. We have different kind of interrupts in our system. We have the external interrupt, non-maskable interrupt, maybe we have the some memory exception interrupt. Okay, together we call it interrupt vector table. And after the ISRs, we will have our normal code, whatever the code we have written. Apart from this, it does the RAM initialization. So before running your main code, whatever the foundation level preparation are there, which is needed to run the microcontroller properly, okay, those things are done in the startup file. So we have one more file which we call Makefile. Make is basically a separate software. In the Windows, we use the C Make. If you are using the Linux, it is already pre-installed. That is GNU Make. When we are doing the build operation, our build should be sequential. So suppose if you have file A.C and B.C and C.C. A.C has dependency on B.C and C.C. First B.C and then C.C should execute, and after this only my A.C compilation should happen. So to achieve this kind of sequence manually, it is very difficult, and maybe difficult in the small project but impossible in the big project. This is one use case. We have one more use case. So suppose if you have a small project, maybe you have few 3, 4, 5, 6 source files are there. You can do everything manually. You can build each and every source code manually, or maybe writing some commands on the command line. If you have hundreds of source files, or let's say 200, 300 source files, so in that case also we should use the Makefile. Create a Makefile. We can say like, okay, which are all the source file is considered. We can even put the condition also. Okay, if this condition satisfied, then consider this source file. In the complete programming step, we saw like we have many steps, right? We have the compilation, we have the assembler, then we have the linker, even flashing step also. All these steps require the separate commands. Each time giving the separate command for 3-4 stages is very hectic and difficult. All those commands we can put into the Makefile, so that when you just execute one Makefile and it will execute all the steps whatever you want. And we will see how we write a basic Makefile.